Hello, guys, and welcome to another session of Intro to Explore ML by DSC NSEC. And today, our topic is simple ML models. So, am I audible? Can you please mention in the comment section? Just wait for a minute. Let's. Okay. So, hello. Hi. I am Avijit Chakraborty. Now, I'm a computer science undergrad at St. Xavier's College, Kolkata, and I'm also a Google Explore ML facilitator. Also, apart from this, I love photography, and there's a few more pastimes that I have. And ML is basically my area of interest, and which is something I've been doing for the past few months. And today, I thank Anubhavda for giving me a chance to take this session. So let's just start. So okay. So today, like this series have all been about machine learning. Now, every time when we look all around us, it's all machine learning everywhere. Like in this picture, this is from a Toy Story. Now, this this is the machine learning is everywhere. Now, why do we say machine learning is everywhere? Take anything that is around us. Take the phone you have. Take our smart homes. Everything contains machine learning. Now, to do this, to do the application of machine learning, what we need is we need something called as ML algorithms. Now, ML algorithms are those logics which actually understands what you want to do, and it takes the input and then it gives the output. So let's today talk about some simple basic models. Now this is a standard representation of any ML models. What it does is it takes an input, then it takes the output also, which is something with say you take the examples and then which is the output. And what does our model return? It returns the rules. The rules are basically the patterns that the model finds in our data set. So, if I what is an ML model? Now, what is an ML model? In the previous slide, what saw is we saw something called as this, like f of x, something input, then an output, and then some rules. So, if we ask about what is ML, it's basically a mathematical function, right? So, today, when we as a ML aspirant or an ML enthusiast, when nowadays when we talk about machine learning models, one thing that comes up very clearly when we hear about machine learning, the next one which comes first is a data. So this is something we all have since because we never need a real input. Now any ML analysis that we see now is this. So we will say yes, this is probably this is the most efficient machine learning model that we have, and it's being widely used everywhere. Like you take any product that has a network within it. But there's something more. because machine learning isn't all about what we are seeing nowadays. This all ML models or this whole theory of machine learning is being dated back quite a few years. So what was being used at that time when neural network was not there? So today we're going to shift our attention from this neural network theory neural network is not the only this. Like that's the agenda for today. I didn't add any particular agenda. This is actually our agenda. No, neural network is not the only agenda, and we have a lot of machine learning to solve the problems that we want. So next, Avengers Assemble. Mhm. Okay, just please. There's been a technical issue. Hello, guys. Am I audible now? Guys, if you could just. You guys just please wait for some time. We will have fixed this. Um, Meanwhile, it was just getting this issue right. Okay, guys, am I audible now? Guys, am I audible now? Um, okay, so okay, so let's just start again. So we are discussing beyond apart from the neural networks, have other machine learning models to help us with our problem. Okay, guys. Meanwhile, just this thing goes right. Let's just continue our discussion here. Okay. What's your favorite machine learning model? Guys, am I audible now? Please just let me know in the comment section. Guys, am I audible now? Guys, please do share in the comment section if I'm audible. So, okay. So today we're gonna discuss some simple machine learning models, which starts with linear regression. Then we're gonna move to logistic regression. Then support vector machine. Then comes k nearest neighbors, decision trees, random forest, and naive based classifier. Okay, I say this. These models are simple just because it's not like a black box what we consider for a neural network, but these models can be examined to in depth so that we can understand what's the flow each step, what the model is doing, and what's the output in each step. So next slide please. So let's start with linear regression. Now, linear regression is a statistical method that allows us to summarize and study the relationships between continuous variables. One variable is denoted as x, which is regarded as an independent variable, and the other is denoted as y. Now, I say about one variable is denoted as x and another is denoted by y. Now, by x, I mean the kind of features that we are looking for a particular problem, and y is our output value. Take the classic example of household price predictions. What that x is? X is the features on which we are looking for, like the number of bedrooms, number of like the size of the house, and if we have a pool or not, etc. And what's y is? Y is the price, the price of that particular house based on the particular features that it has. So in this slide, you can see this is. Can you go to the previous slide, please? Okay, thank you. So in this slide, you can see it says theta1 x1, then theta2 x2. Now this theta0, theta1, and theta2 are basically the weights on each feature. Next slide. Now what's that h theta meant? H theta meant that we get a straight line, because since it was a linear function, so this kind of machine learning models like the linear regression gives us a straight line which fit to our particular data set. Now what these data points are? These data points are being plotted based on the features and the feature values that we have. Next slide. Now, linear regression, as the name says, find a linear curved solution to every problem. Like you take any problem, if we try to solve it using a linear regression, what it will do is it will always find a linear solution to that problem. Now, this can be problematic because yes, because it does not work if our data is linear. if our data doesn't go with two dimensions. So for that, we have some other models which we will be seeing later on. Next up is the advantages of a linear regression model. Yes, it's easy and simple implementation because linear regression is something we all study in our high school. Yes, this is space complex solution and obviously faster training because you're gonna work with numbers. Hence, it's a faster training. Next up, once we are done with our regression thing, next up we have logistic regression. Now, logistic regression. What it does is our classic classification task. Say we're gonna classify a mail, whether it's a spam or a not spam, whether our say a particular text it has a positive sentiment or a negative sentiment. Task. This kind of binary classification task is being done using logistic regression. Let's go to the model. Next slide, please. Okay. So logistic regression says it's same as it's a regression. So what it does is it basically takes the output from a regression model and then it feeds that output to a function gz. Now gz is 1 by 1 plus e to the power minus z. Can anybody say what this function is? Okay, this is a sigmoid function. Click next. Okay, gz is a sigmoid function. Now what does the sigmoid function do? If our the value of h theta, if it is greater than 0.5, then it will output as 1, and if our value is less than 0.5, it will output as 0. Now this is how a logistic regression curve looks like. This particular curve that we have is a sigmoid function. Now you can see in y equal to 1 we have a particular data points. It means those data points has been classified to the type of 1, and in the down below we have some data points at y equal to 0. Now this has been classified to the type 0. The next model that we have is k nearest neighbor. Now, as the name suggests, it searches nearest neighbor. Now, what does this nearest neighbor mean? K nearest neighbor is a non-parametric method used for classification as well as regression. It is one of the most easy ML technique. Now, why easy ML technique? Next slide, please. Next slide. Okay. So the basic logic behind a KNN is to explore your neighborhood, assuming the test data points should be similar to them, and derive the output. In KNN, we look for K neighbors and come up with a prediction. Now, if you can see the image on the left, we have a particular data set. When we so we see some. Am I audible now? Okay, so we see some data points that lie near to the axis and some data points which are farther to the axis. Now, what k nearest neighbor does is particular neighbor, like here it is marked using a green box, and here it's marked using a red box. Now, what it does is it basically calculates the distance from that neighbor to the surrounding data points. And if it says the distance falls within a particular threshold range, it takes that particular data point into its neighborhood, and the other data points it takes to the next neighborhood. Okay, so what? Can we go back to the previous slide? Okay, next slide. Okay, so K nearest previous slide, previous slide. Okay, so let me repeat neighbor is. Now what K nearest neighbor does is it basically takes the entire and then it select a particular neighbor. Now K is basically the number of neighbors that we have. Next slide please. So in here we can see it selects a particular neighbor as denoted by the green box, and then it selects another neighbor denoted by the red box. Now what it does is it tests the distance of a particular data point from that particular neighbor, and it says which particular data point has the minimum distance. Because what does neighborhood mean? Neighborhood basically the people who live close nearby. So the logic remains the same. Here we calculate the data points that are at a minimum distance, and they are being taken to that particular cluster. Next slide. So there are a few things that we need to keep in mind, which is the value of k and the distance function. Now why do I say a value of k? Say you have a particular data set, and there are students, like there are people from uh, say you have a particular, you take a particular population, and then you find out like how, on how many, what basis of the country you can classify them. And it turns out that you have actually 5 country people. But what you do is you set the value of k to 2, which is something that you try to classify them on based on 2 country names, which is not viable for this particular data set. So what we do is the value of k must be according to the particular problem statement. Next up is the distance function. Now distance function is basically the kind of distance function that the model uses to calculate the distance from the neighbor and the next data point. Next up. Okay, so K should be wisely selected because you cannot determine you can successfully classify the cluster. Next, since it changes the data set, since it checks the distance of every data point, so computation time is huge, because if you have a large number of data points and if your model needs to check the distance all those data points, the computation time will also be increases, and hence the time increases and also the cost. Next up, we have our another model, which is support vector machines. Now, support vector machine is a type of ML technique that can be used again for both classification and regression. It has majorly 2 variants to support, that is linear and non-linear. Remember in the linear regression section, what we discussed is if our data representation is linear, the particular solution given by the linear regression will be fit for that model. But what if our data representation is non-linear? There a linear regression model won't work. So what we can do is we can use something called a support vector machine. What it does is, rather than drawing a particular line between a particular point, it draws a particular hyperplane. Now if you can imagine a multi-dimensional space, show the next image. Okay. On the left corner, we have a particular data set which is something similar to the data set that we saw in our linear regression tasks. So here a particular line can classify between the red dots and the blue dots. Now what if our representation is something like, next please. Okay, so what if our representation is something like this? We have a 3D image where you can see the red dots lie on the top and we have green dots lying on the bottom. So a particular line won't be en- won't be enough to classify them. So what we need is we need a hyperplane. We need a plane that will be distinguishing between these two examples. So on top, the example was of a linear SVM, and on the below it was the example of a non-linear SVM. Next up, how does this SVM work? This SVM basically uses something called as kernel. Now, kernel is a class of algorithms used for pattern analysis. So, and the best known member of this is the SVM. Now, our next model is decision trees. Now, if you think of an ML task, it's all about taking a particular decision at each step. Now, decision tree is a tree-based algorithm used to solve regression and classification problem. An inverted tree is framed, which is branched off from a homogeneous probability distributed root node to another leaf nodes. Now, this particular problem where you have some ones and now if you see the ones have underlines and the zeros have are not underlined, but also there is a particular variant in the zeros section. We have a set of zeros with the blue color and we have a set of zeros with the red color. Now say this, since this is a decision tree, what it does is it asks question at each step. Say for this on the first step, whether the color is red or not. If it's red, it takes this as input. Say it takes 1, 1 and 0. If the color is no, that is it's not a red. In this case, it's a blue. So it takes all those blues aside on the right hand side. Next up, it asks whether the digits are underlined or not. If it's underlined, it takes them to the yes section. If it's not, then again it takes them to the right. Now, here what it does is the model basically tries to identify the features that is present. The model is basically trying to understand the feature that is present for that particular data set. In this case, it's whether the digit is in red or whether the digit is underlined. So are we okay till now? Are we okay till that? The model discussed that we had. Please let me know if you have any questions in the comment section. Okay, this particular data set can also be approached another way. Like say you want to approach with the say you want to ask the first question as say whether it's underlined or not. So in the if you say if it's underlined or not, then at first it will question depends very on the model whether it okay. So this process of asking question at repeated steps allows the model to identify the features. Okay. Okay, so what I asked about is, if we approach this particular data set, say we ask the question at first, the output would have been 1 1 on left and all the zeros to the right, right? So after that, if we would have asked whether the particular digit, okay, so whether the particular digit is in, am I audible now? Audible now? Okay. So so what I'm saying is, if you approach this particular data set in some other way, where we ask the is underlined question at first, and we ask the question whether it's a red in second, so we would get a, so we would get a different representation of this, where at first you would have got all the ones on the left and all the zeros on the right, and on our right subtree we would have asked whether if it's red or not. Then we could have classified it as the red zero on the left and all the blue zeros on the right. So are we up till this? Next slide, please. And next slide. Okay. So if we take another problem statement, the Titanic dataset problem, it's very popular, I guess, right? Okay. So in this particular Titanic dataset, if you want to say whether a particular survivor, whether a particular passenger will survive or not. Not. So what are the questions that come? So in this way, you can frame the questions. Say we at first ask the passenger is male or not. So if the passenger is so if we ask whether the passenger is male or not, so in this case, if the uh, can we get the slide on screen? Uh, is audible? Is the voice clear now? Are we on the Titanic dataset slide? I still then keep asking questions if you have any till now. We have discussed a few models till now. Okay, so in this particular Titanic dataset problem, what it says is whether a particular passenger will survive or not. Our task to predict whether a particular passenger will be surviving or not. So if we particular this data set and the the tree needs to find out the particular survivor, the particular passenger will be surviving or not. Model basically asks question on the data set. So what the first question it asks? It asks whether the sex is male or not. So it's not male. That means if it's a female, so there's a chance that she has survived. Now, if the sex is male, so any questions till now? Guys, please let me know in the comments. Until now, until now,
Hey guys, am I audible? This is Ritvik. Go ahead and tell me if I'm audible. Hi, this is Ritvik. Am I audible? Okay. Uh, so as you can see that we are unable to go ahead with the session that was planned for today, which was simple learning models by Avijit. Now, this is purely due to a technical reason. There is some interference on both of our sides, and I know that is regrettable and that is not what we want. But unfortunately, it's what is happening right now. So I would request you all to shift your questions to the forum or to the WhatsApp group or Slack group. And again, on behalf of the entire NSEC Intro to ML team, I apologize um, for the kind of session that we could deliver today. Having said that, this session, whatever has been left incomplete by Avijit due to these technical reasons, will be covered again by him in some future session. It might not be tomorrow or day after tomorrow. We'll try to make it as soon as possible. In the meantime, I urge all of you to go ahead and open the forum and the WhatsApp group and the Slack group and post your questions there, your doubts, your queries, and your feedback there. Also, just hold on a second. Uh, Let me share something. Yeah. So if you want to get in touch with Avijit, this is where you get in touch with him. I am taking the liberty of using two of his slides because his voice is not audible right now. But if you want to get in touch with Avijit, this is where you get in touch with him, and you know where to post your questions, you know where to post your queries and everything. Again, really sorry uh, for all the inconvenience that was caused due to these technical reasons. And yeah, this is from Avijit and also the entire DSC NSEC team. So yeah, happy Durga Puja to all of you. I guess that was all from my side. Yes, yes, Faiz, you will get the slides. Everyone who is wondering if you can get the slides, it will be posted in the group as usual. But I also finish with a promise that this session will the incomplete part of this session will be carried forward in a future session by none other than Avijit again. So yeah, that's it. That's it. And I'm signing off. Thank you guys and good night.